Good morning, everybody. Hopefully we're doing well. Looks like we might have been losing a few people to maybe illness or the holiday season. Let's go with some green checks to get started, and then if you had any questions about learning guide, any of the notes we did, anything related to Unit 7, this is it. We've done it. There's only 3 units, so there's not, or 3 lessons, I should say, not a lot to do here. I wanted to mention a few things about the course while you guys are maybe putting some questions in. When you first log into Math now, at the top of the page, I've made a little questionnaire here, and it has I think it's 10 questions just on a scale of 1 to 5 sort of thing. So if you wouldn't mind, if you could find some time to fill that out, and it'll just help me moving forward, maybe designing lessons differently, or just kind of taking your guys' feedback and changing things to make it better for you. And then even longer term, looking at maybe science. If there's some things that you really like about this math course, we can use them in science. If there's things that you don't like, then we don't have to do them moving forward. Remember, this is the first time we've done it kind of online with the studio and using these Moodle courses at the same time and things like that. So if you wouldn't mind, it'd take you less than 5 minutes, maybe 3 minutes. If you go through that, I would really appreciate it. Maybe some point in the next few days. I would hope, if at all possible, you could get your learning guide submitted today, and then you could have the test written before you get back from the break. I would probably want to write it on Friday if I had my learning guide done, but I'll leave it up to you. I'm also going to open up Unit 8 today as well, which is the one we're going to start after the break. And I pre-recorded all of the lessons for Unit 8, and if you want to look at it, it's there. I know that you guys have well-deserved a break, so don't think that you need to look at Unit 8, but it is there. So if you want to look at it over the break, it can be done. And then when we get back, basically there's 3 or 4 lessons, and then we're going to just start preparing for the provincial exam for the last couple of weeks. So that's kind of where we're at. If you are a bit behind, this break would be a great opportunity for you to get caught up, because remember, at the end of the course, we have hard deadlines. The last day of the semester is the last day of the semester. We can't extend the semester. That's it. If you don't have your stuff done by then unfortunately, we can't just give you extra time. The provincial exam, we're still waiting for a date. We'll have that for sure after the break, because we're going to do a digital exam, so they can pick any day along that provincial exam week. So once we get a confirmed date, we'll let you know when that is. And then we'll let you know when we're going to have another math exam at Central. So we'll let you know when that's going to happen as well. So lots of stuff happening after the break. A couple people put in some questions. Ava, page 6C, page 7.5, page 310C, and page 6, number 4. Okay, so we'll get to all those. We have an hour, so if we don't have enough questions to fill the hour, then I guess we're just done. You guys can finish the learning guide off and get it submitted, and we'll go from there. All right, so the first thing, page 6C and page 7, number 5. Page 6C. I assume you're talking about this one because it's the only one there. That looks like a bit of a mess. What is it asking? Solve the following linear system algebraically by substitution. All right. I'm sure there's lots of different ways to do it, but I'm thinking if I expanded the brackets out and then combined like terms, I could then probably solve this system. Trying to think if there's an easier way, but I'm not seeing it right away. So I'm just going to kind of go with my gut here, and we'll figure it out. So I'm going to label my equations 1 and 2. And then the first one I'm going to deal with over here. So I'm going to expand this through the brackets, I'm going to expand that. So I'm going to get 4 minus 8x, which is equal to 9 minus 3y minus 12. And then I'm going to combine any like terms I have. So I have a 9 here, and I have a negative 12. So I'm going to combine those together. So I have 4 minus 8x, and then 9 and negative 12 is going to give me negative 3. And then maybe I'll just leave it there for now. See what happens with this second equation. Maybe something magical will happen, and I'll get some a variable that has the same coefficient in front. So 2 times 3 is going to give me 6x minus 2, and then negative y minus 4 is negative 7. 6x minus y minus 6 is negative 7. I'm thinking, just looking at what I have here, I noticed that I have no coefficient in front of my y term. So that might be a good candidate to isolate that, and then I can substitute that into the y on my other equation, my second, or I guess technically my first equation. So I'm just going to go with that. This is the substitution section, so I'm going to do that. So I'm going to add y to both sides. Change my color. 6x minus 6 is negative 7 plus y. And I'm going to add 7 to both sides. So I'm going to get 6x minus 1 is y. Sorry, 6x plus 1. It's negative 6 plus 7 is plus 1. All right, I'm going to substitute now. The 6x plus 1 is equal to y, so I'm going to put it into my other equation over here. So I'm going to get 4 minus 8x is negative 3 times 6x plus 1. And then minus 3. And I'm going to expand this. 4 minus 8x is 3 times 6 is negative 18x. 3 times 1 is negative 3 minus 3. Let's get my x's to the left. I'll add 18x to both sides. So I get 4 plus 10x is negative 6. I'm going to subtract 4 from both sides. 10x is negative 10. And then I divide both sides by 10, and I get x is negative 1. I'm kind of happy with that. That looks like it worked out nicely for x. Okay, so I have x is negative 1. I need to plug it into one of my two equations to end up with y now. So it doesn't matter which one I choose. Maybe I'll choose the second one here. So I'm going to take equation number 2, which was, myself some room, 6x minus 2 minus y minus 4 is negative 7. So I'm just taking the equation from right here. And I know x is minus 1. So I'm going to get 6 times negative 1 minus 2 minus y minus 4 is negative 7. So carrying on, negative 6 minus 2 minus y minus 4 is negative 7. Combining like terms, I have a negative 6, a negative 2, and a negative 4. So negative 6 and a negative 4 is going to give me negative 10, and then another 2 is going to give me negative 12. So negative 12 minus y is negative 7. I'm going to add 12 to both sides. 7 plus 12 is going to give me 3, 4, 5. And I get y is negative 5. So my solution in this case is going to be negative 1, negative 5. I'm not sure how you ended up with weird fractions. It's possible that what I've just done is all completely wrong. Just kind of blasting through that real quick, but yeah, I don't know even what the answer is, so if that's wrong, then I apologize. Not much point in me helping you if I'm doing things incorrectly. All right, I like being right, but I do make mistakes, so that's a difficult question. Don't kid yourself. That's like as hard as they are going to get for this section. So, I mean, if you attempted it and got somewhere with it, there's lots of things to kind of follow through with on there, especially with this algebra and the substitution method, because you're always expanding and then combining like terms, then expanding, combining like terms, and then moving things. That's a tricky question. I don't think you'll ever see another one like that. But I'm always surprised by what ends up happening. So page 6C, that was it. And page 7, number 5. Okay, I'm right. Oh, that's a big relief, actually, because that was a tough one. Page 7, number 5. You know what? I sat down and I looked at this question before I came into the studio this morning, and I took a quick glance at it and I got it wrong the first time I did it, and I'm like, oh no, what did I do? So then I went through it again and figured it out, but this is another tough one. So let's follow the information that we're given. An amount of acid at 40% solution is to be mixed with enough at 10% to make a 25% solution. If there are to be 20 liters of final mixture, how much of each solution should be mixed together? So, I mean, if you don't like the thinking about it in terms of solutions, you can think about it in terms of dollars if you want. You can think like, you know, some amount of money is invested at 40%, some is invested at 10%, and then you want to end up with 25% in the end. And then you have, you know, 20 liters or $20 to start with. And that's that. So, see what we can do here. So we have some amount at 40%. So I'm going to go let x equal the amount at 40%. And then we have some amount at 10%. So let's go let y equal the amount at 10%. So these are our two amounts. We're good there. Okay, it says there are 20 liters in total. So if I took the amount at 40%, and I added to it the amount at 10%, I should end up with, oh, it wasn't open for that, I should end up with 20 liters in total. So that would be my first equation. So that one was the easy one. The second equation is going to be the percentages. So I have 40%, know where to start here, second equation here. I have 40%, which is 0.40, times that first amount, or 40% invested at X dollars, if you want to think of it that way. And then I'm going to add to it 10%, or 0.1, I guess I don't need the percentage in there, times the concentration of 10% at the volume of Y, and then that's going to equal, and this is where I got mixed up. Now, we want to end up with a solution at 25%. So 25% as a decimal is 0.25. And that's what I left it as, and then I did the question and it ended up being wrong. So I was like, oh no. And then I thought back, what am I doing on the left side here? I'm taking a concentration and I'm multiplying it by a volume. then I'm taking a concentration and multiplying it by a volume, and I'm taking a concentration and I need to multiply it by a volume. So what volume in the end do we want to be at this 25%? Well, the question says that there's 20 liters there. So we want that 20 liters to be at that 25%. So that is my second equation. And that is where I made my mistake. I forgot to take the volume and add it in there. So we can solve this however we want. We can graph it if we want, which is going to be really, really difficult because we have some decimals. So I'm not going to graph it. I could do elimination if I wanted, but none of my coefficients are the same in front of my x's or y's, so that's probably not going to work. So I'm thinking substitution's probably going to be the best way. So I have this first equation here, and I can just solve for either x or y, shouldn't matter. Let's go x is equal to 20 minus y. So I'm going to plug that into the x here. I'm going to go 0.40 times 20 minus y, and then plus 0.10 times y, pardon me, 0.25 times 20. I shouldn't have to plug that into my calculator because it's 5, but there we go, quarter of 20. All right, both of you guys recognized your mistake. I'll just finish it off. Maybe I'll just find x, and then y is going to be pretty straightforward after that. I'm going to expand this out. So I'm going to go 0.4 times 20. It's going to give me 8, I think. Indeed it does. 8 minus 0.4y. I guess I could put the 0 in there, 40y. Plus 0.10y is equal to 5. I'm going to combine my y's together. 0.4 plus 1, so I have negative 0.4 plus 0.1, give me negative 0.3. That's equal to 5. I'm going to subtract 8 from both sides to get the y by itself. So negative 0.30y is negative 3. And then divide both sides by 0.30, negative 0.30, and I end up with y is equal to 10. So if my two amounts have to add up to 20, I have x plus y is 20. I know y is 10. That means x plus 10 is 20. X is equal to 10 as well. So my two solutions are going to be 10 and 10. All right. So that was another difficult question. I'm thinking that the first equation that we had here, this x plus y is 20, that would have been easy to come up with. But the second one, this big long guy here, that would have been a bit more difficult. But now that you've seen one, hopefully you remember the little trick, taking the concentration at 25%, multiplying by the total volume, and getting the right solution there. All right, so that's 2 down. What do we have left? 6C, page 7, number 5, done those. Page 3, number 10C. Page 3, number 10C. Okay, I think this is asking how many solutions for the following system. All right. So if I can convert these both into slope-intercept form, I can then compare them. If they have the same slope, they're parallel. If they have the same slope and y-intercept, then they are Alex, you crack me up. I can't even concentrate when you're asking questions like that. Can you break glass by singing? Yeah. Yeah, they actually did it on Mythbusters. You should Google it. It's there online. Guy broke a glass with his voice. It has to do with resonance. You can also break bridges with resonance. Google Tacoma Narrows Bridge, and you'll see how wind took down a bridge in Tacoma, Washington. Interesting stuff. Not related to math, though. All right, so let's solve for y. These are... All right. So we have two equations, 1 and 2. I'm going to whip through this. We have 10x minus 15y is 45. So I'm going to move the 15 to the right. And then I'm going to move the 45 to the left. So just rearranging everything. And Alex, that is exactly true. Everything has a natural frequency. It's called resonance frequency. Everything starts vibrating, and then the vibrations get bigger and bigger, kind of like on a swing. You start really slow on a swing, and then you push high, and you get higher and higher and higher until you get really big. Things break eventually. All right, I'm going to divide everything by 15. And I'm going to end up with 2 over 3x. 45 divided by 15 is 3, is y. All right, so that's equation number 1. Do the same thing with equation number 2. See what happens. I'm going to move the 40 to the right. I'm going to move the 40 to the left, I should say, 20 to the right. And then divide everything by 20. 8 and 20 is going to give me 4 and 10, which is going to give me 4 goes into there, 2x. 2 over 5x. 40 divided by 20 is going to give me 2 is y. So immediately I see that my slopes are different. As soon as my slopes are different, I have one solution. Just immediately. As soon as I see that, I don't even need to do anything else. Because I have different slopes, that means my lines are going to cross at exactly one point. 2 over 3, 2 over 5. And one solution. There we go. What else did we have? Look at you guys. You're all curious about science. I'm excited for science. You guys seem like you're going to enjoy science a lot. Page 310, page 6, number 4. I don't think I've done that one either. All right, so another one of these word problems, converting it into a system, 2 equations, then solving the system. Maybe I will figure out the equations for you guys, and I will let you solve them, because I don't want to do too much for you. So the theater sells tickets for $4.50 and $6. Total of 380 tickets are sold, and then you end up with this $1,972.50. How many tickets were sold at each price? All right. We're going to need to I'm going to pick x and y. X equal number of tickets at $4.50, and let y equal number of tickets at $6. So you can see that these all have this kind of theme. You're always going to have 2 variables, 2 things, 2 different amounts invested, 2 different ticket prices, 2 concentrations, and you end up with some equations. I'll get to your question in a second. Let's finish this off. So if I take my first equation, the number of tickets at $4.50 plus the number of tickets at $6, I'm going to end up with 380 tickets. That's how many questions were sold in total. My second equation is perhaps the bit trickier one. I have $4.50 times, I guess I don't need a bracket, times the number of tickets at X dollars plus $6 times the number of tickets at Y dollars, and that in total is going to be the total amount of money that we have. So from there, with that first equation being X plus Y is 380, you're probably going to look at a substitution type solution. So you're going to isolate X. So 380 minus Y, plug that in to the second equation, and then solve for Y, go back, solve for X, and see what you end up with. So that'll be a good thing for you guys to do to finish that off, practice your substitution. If you're still having issues with it, I can always do a solution for you and post it online, but I have a feeling you should be okay. I'm trying to get that done. The question was, what do I like better, math or science? Math's easier to teach because it's kind of really sequential and concrete. Science is a little bit more flexibility, and I like the science material better, but I like teaching math better. So we have a lot more fun in science. Math's kind of boring and dry in a lot of spots. So I don't know if that answers your question. And Alex, we'll get to that next semester, I promise. We'll talk a lot about hydrogen. All right, I have any more questions? I think Abby had something, said like, if you have time, Mr. Borden, could you please do this? I'm getting lost in my chat. So I got Ava's 2 questions. I have Taylor's 2 questions. Abby asked, learning guide, page 6, letter C at the top, page 7, number 5. So I did C at the top, and I did page 7, number 5. So I got those 2 for Abby. Well, we went over D on the top of page 5, so in the end, could we do that? D at the top of page 5. Abby, did you want me to go through it again? Is that what you're hoping for? I can do that. Definitely have time. And just looking for other questions. Okay, so definitely go through this guy again if you want. Yeah, definitely. Did anybody have any other questions? Well, I'm going through this guy. And then, yeah, no worries. We have time, Abby. We have 30 minutes and nowhere to go. So we can definitely do that. If I missed your question, I apologize. Everything kind of gets really high up in the scroll and I lose sight. Okay, let's start right from the beginning again, because this is maybe a more common question that you're going to run into, and it's important that we kind of understand how to do it. Now, it turned out that I just kind of got lucky on it when I did it the first time. It's maybe designed to work out easily. So anytime, this is in the elimination section, right? Yeah, elimination, perfect. One thing I should mention is that you should know on like a multiple choice test or something like that, even though it says substitute or elimination or graphing, what they'll do to kind of force you to know how to do the elimination method is they'll show you somebody's work. They'll say, this is their first step, this is their second step, this is their third step. And the work that they're showing you will be solving by elimination. And if at some point they made a mistake, you need to find the mistake in their question. So you're thinking, well, how are they going to know which method I choose? They won't. But some questions, they'll actually show you somebody else's work, just, a question that somebody has gone through. And they'll make a mistake in one of the steps, and they'll say, which step was the error made, or something along those lines. So as soon as I look at D, I see that there are fractions. And I don't like dealing with fractions. So if I can multiply everything, it's an equation, I can multiply both sides by a number to get rid of all of my fractions, then I'm going to do that. So the first equation here, we'll call this 1, we'll call this 2. The first equation has fraction of a half and a fraction of 2/3. So I'm not really concerned with the numerator, the top. I'm just concerned about the bottom, the denominator. So my denominator is 2 and 3. So if I multiply the first one by 2, that's going to get rid of that. But I need to multiply everything by the same number. So I'm going to have to multiply the first one by 2, and then the y coefficient by 3. So I could do 2 steps, or I could just multiply everything by 6. So what I'm really doing is multiplying everything by 2 and 3. Or you can just think of it as multiplying by 6. Because that's the least common multiple of those denominators, the 2 and the 3. So multiplying everything by 6. So I'm going to get 6 over 2 times x minus 12 over 3 times y, and 6 times 6 is 36. Now I can simplify my fractions. 6 over 2 is 3x, 12 over 3 is 4y, and then 36. So what I've done is I've just got rid of my fractions, which is a good thing. Same process for the second one now. I have a quarter and a third. So if I multiply everything in the first by 4, that's going to get rid of the 4 on the bottom, and then everything in the second term needs to be multiplied by 3, and that'll get rid of the 3. So 4 times 3, or just multiply everything by 12. So I'm going to lose the 4 and the 3 and just think 12. Multiply the first, the second, and the third. So let's go with this being my first equation. Here's my second equation. I'm going to get 12 over 4 times x plus 12 over 3 times y is negative 12. Negative 1 times 12. I'm going to do my division. I'm going to get 3x plus 4y is negative 12. Now, was that the tricky part for you, Abby, or was it more the actual elimination of these two equations? Because that's kind of, the first step. And then we need to kind of figure out which one we want to get rid of. The actual elimination. Okay, so assuming we can get rid of the fractions, we're doing okay. And we're going to write the equations on top of each other. So I'm going to go 1 and 2. Equation 1 is 3x minus 4y is 36. And then I'm going to have 3x plus 4y is negative 12. So those are my two equations. I've lined them up. My x's on top of my x's, my y's on top of my y's, and my 36 on top of my negative 12. Taylor, I'm not sure where you're coming from with the, I thought you divided the 12 by the denominator. I'm just seeing 12s here. So I took 12 divided by 4 is 3, and then 12 divided by 3 is 4. I didn't have any denominators over here, so I'm a bit confused. Maybe somebody can help me out. Well, somebody tries to help me out. I'm looking at my two equations, 1 and 2, and then I need to decide, am I going to add these things together? Or am I going to subtract them? And you could pick either. You could, if you added them together, the y's go away. If you subtracted them, the x goes away. So you could pick either or. I think adding is a little bit easier. I like adding better than I like subtracting. So that's what I'm going to go with. I'm going to go with addition, and I'm going to add the equations together. All right, so Taylor, no, like in the original question, I thought you divide 12 by the denominator. I'm not following where you're coming from, Taylor, I'm sorry. 12 by the denominator. I'm just going to carry on, and if somebody can help me out, or maybe it'll just make sense to you, Taylor. So I'm adding these things together. The reason I can add them together is because the signs of my 4y and my negative 4y are different. So as soon as I add these together, negative 4 plus 4 gives me 0y. And I need to eliminate one of my variables in order for this to work. Now, I mentioned this last time I did the question. If I maybe didn't see that those signs were different, and I said, okay, let's subtract. Well, now 3 minus 3 gives me 0x. And then I'm going to go negative 4 minus 4 is going to give me negative 8y. And then 36 minus 12 is going to give me 48. So I could do it that way if I wanted. All right, Damon. Or I could add them. If I added them, I end up with 6x. My y's go away, and then 36 plus negative 12 is 24. Then x is equal to 24 over 6 is 4. So that is that. Once I figure out x, I can solve for y. So I could go 3 times 4 plus 4y is negative 12. Uh, 12 and 12, negative 24, y is negative 6. I'm hoping that's what I got last time. I don't remember. 3 and 4 is 12, 4y, 12 minus 12 is 24. I'm thinking we're okay there. So Abby, I hope that clarified what you're having issues with. Is there anything specific that I can point out? Because that is a question that you will likely encounter either on the test or provincial. It's a fair question. It's not like a super difficult one. It's just, it's difficult. It's not super difficult. Hopefully that helps. You didn't multiply 1 in the second equation by 12. So you didn't have the negative 12 here. That'll get you. So just a simple kind of math error, and then it just puts everything on the wrong track, and you end up with the wrong answer. But you can always check, which is nice. You can plug the point 4, negative 6 into the equations and see what you end up with. And if you do end up with the wrong answer, then you need to go back and look at your stuff again. One thing that I find helpful, just in writing tests in general, if I go through a question and I get it wrong, and I know I've got it wrong, maybe I've checked, or maybe the answer isn't there, sometimes if you try to follow your work again and look what you've written, sometimes it's hard to find your error. So every once in a while, when I'm doing a test, I get a question wrong, I would, instead of trying to find my error, if I can't just immediately locate what I've done, is I'll just grab a new piece of paper and I'll just start from fresh again and just do the question twice. And then if I end up with the same answer the second time, then, I need to go back and look harder. But sometimes you've just done a simple sign error, or you've, forgot to multiply a 1 and a 12, and it'll kind of fix itself the second time you do it. Because if it's something that is a math error or a sign error, by doing it again, you're probably going to do it right the second time if you take your time thinking about it a little more deeply. But if it's an actual math understanding thing, like you don't understand the process and you get the same answer twice, then it's likely that you just don't know how to do the question. So that's kind of a strategy you can use to write these tests. And before you guys sit down to write the provincial exam, I'll go through lots of different strategies on how to make the provincial exam manageable. There's lots of things we can do. Generally, there'll be four solutions, so A, B, C, and D. By just knowing a little bit of information, you can generally eliminate 2 of the answers. So now, instead of it being if you don't know how to do it, instead of it being a 25% chance of getting it right, now you're up to 50-50. And you can do that with nearly every question on the provincial exam, knowing just a little bit of information. So we'll look at how we can do that. The provincial exam's 20% of your overall grade. So what we're going to do is once we finish the course in Moodle, we'll look at your grade and we're going to multiply that by 0.8. And then the provincial exam mark is going to get multiplied by 0.2. We're going to add them together. So the in-class is 20%. Provincial exam is, in-class is 80. Provincial exam is 20. That's how it breaks down. That's it for Unit 7. I don't think anybody has any questions that I missed. And I'm going to leave it there. Unfortunately, I don't have an opportunity to come to the movie today. I have to teach my ADC class, but I think Mrs. Wood is coming. And yeah, Alex, 50% or 20% is a lot for one test. When you get into university and further, you can have one exam, like a final exam, count for up to like 80% of your grade. So 20% doesn't really seem like a lot compared to 80% or more. We've done courses with just a test at the end and that was your grade. So yeah, it's kind of crazy. It depends on the teacher, especially in university. High school is a little bit different, but if you do move on, you might end up with courses where just a term paper, like one essay is your entire grade for the entire course. So something to consider. I hope you guys have a really great break. I mentioned this the other day. I will check my email on Monday, like in four days from now, to see if anybody submitted learning guides. If you have, I'll send out the test passwords for you so you can write them over the break. And then I can't guarantee I'll check the following Monday. I'll try really hard, but if I get busy, I might not. So definitely the first Monday, and then I probably won't look at anything until the following Monday. So if you want to get a test password over the break, it needs to be done by the first Monday or the second Monday, and that'll give me time to look at it and then send off the password to you so you have an opportunity to write that test or tests. Since I have a couple minutes, I will mention again that I think it was last week I said that if you wanted to rewrite one of your unit exams, I'll take the higher of the mark, of course. So if you got like 12 out of 20 on one of the tests and you wanted to redo that unit, maybe unit 1 or 2 or whatever the case may be, if you can show me evidence that you have done maybe some of the additional problems from the course or maybe gone through the corrections to your test, anything like that, and I think the amount of preparation you've done is worthy of a rewrite, I'll unlock a second writing of a test for you. So we can do that with any unit you want. Let's keep that until after the break, because after the break, we're going to start to review units 1 through 8, so all of them. And then sometimes you're like, oh, I can't believe I didn't understand this while I was doing it. It just makes so much more sense now. And hopefully that's the case. So I'll leave that offer on the table. We'll deal with it after the break. I don't want you guys to be stressing out about math over the break. I want you guys to relax, enjoy some time, peace and quiet, maybe with family, friends, whatever the case may be. And that's it. So have a great break. Have a happy new year. And I will see you guys on the first Monday after the break at 9:05. We're right away after the break. Take care.